So now we've solved for the currents. So let's take a look at what this is telling us. So current 1 is positive, so we have the arrow and the polarity in the correct orientation. For I2, we see that the current is negative, so it's actually flowing down through R4, so our polarity is backwards, which is not a problem. I'm good with it. I3 is backwards because it's negative. It's flowing in the opposite direction. I4 is negative, so it's also flowing in the opposite direction. And I5 is in the positive, so it's flowing in the correct direction based on this circuit. Now, let's go and solve for the rest of the voltages. So we have VR1 is equal to I1 times R1, and that gives me 5.958 volts. VR2, put it over here, is equal to I3R2, and that gives me minus 2.35 volts. VR3 is equal to I3, oh no, I'm sorry, I5 R3, and that's 0.308 volts. And we have VR4, and that's equal to negative, sorry, jumping ahead, that's I2 R4, and that's equal to negative 6.042 volts. And VR5 is equal to I4 R5, and that's equal to negative 3.692 volts. Now the beauty of these circuits is we have a lot of different ways to test them. And so I'm pretty strict about these circuits because usually people say, oh, it's hard, and well, you can check your answer. It's very simple. So let's look at our Kirchhoff's voltage law. So if I take plus V1 minus VR1 plus R4, and that's equal to 0, I'm sorry, VR4, so we have 12 volts minus voltage across VR1 is 5.958 volts, and then plus VR4, and that's going to be a minus 6.042 volts. And does that equal to 0? Well, yes, these two are going to add up to minus 12, and we have plus 12, so we have 0 volts is equal to 0 volts. So that's correct. Look at the next one. Minus VR4 keeps wanting to write a 9 on me. Minus VR4 plus VR2 plus VR5 is equal to 0. And I'm going to have minus VR4 is going to be a minus 6.042 volts plus VR2. VR2 is minus 2.35 volts plus VR5 is a negative 3.692 volts, and that gets me pretty close to 0. Let's see, there's going to be off just a little bit, but it's approximately equal to 0. So it's rounding errors at that point. And then the last, minus VR5 plus VR3 minus V2 equals 0. So we have minus a negative 3.692 volts, and plus we have plus VR3. VR3 is 0.308 minus 4 volts, and that is going to equal 0 volts. So those are correct, and I can check my currents. I have I5 plus I4 minus I3, and so that's going to be I5 is 5.594 milliamps plus I4 is going to be minus 0.123 amps minus I3. I3 is minus 0.117 amps, and if I add those up, I'm going to get 0 amps. And for the last one, we have I1 plus I2 plus I3 equals 0. I1 is 0.238. I2 negative 0.121. And I3 is a negative 0.117 amps. And if I add those up, actually subtracting and adding, I'm going to come up with 0 amps. So this circuit is complete and it's tested, and we've made sure that we're correct. And this is how you solve a circuit using branch method.